Hello, how are you? What I want to do in this video, excuse me, is talk about the debugger that we have in the Visual Studio version of C++. The debugger allows you to run a program up to a particular point and then look at the variables, and then you can go on from there. It's better than writing out the variables because you can see more of them and you can decide what to do next after you see them. To set up a place for the computer to stop and let you get in and look at things, you have to put in what's called a breakpoint. You put in breakpoints by clicking in the extreme left in this gray area. A little red dot should appear. Under debug, if you want to get rid of them, you say delete all breakpoints. You also can do it probably by clicking on it. I've had that work a few times. There are two keys, and they're both visible on this drop-down menu. F5 starts the debugging, and F11 goes one instruction at a time. I'm going to use those two to watch this program. I put in two separate places. And I tell you that when I get to line 59 in the program will not execute line 59. It will instead stop. And that's my breakpoint. I'll look there and see what happens. So I have to be within the program when I do this. And what I'm going to do is start by F5, which says start the debugging. Now, as happens sometimes, the window that I need to see things in is invisible. So I go here and I say reset window layout, hit yes, and now it gives me what I need. This is the part that I want to look at. This shows me, when I click on local, it shows me all the variables that are in scope, and I can see what they are. Now I will tell you that X is my priority array, and the items that are in X are trees. Right now, X is empty, size 0. It just doesn't have anything in it. And the heap is empty. This is the place where the values are going to go. So the next step is F11. I have gotten something turned on again that I don't know why I turned it on, but it's turned on. And I can't seem to, I think if I ignore it, it'll go away. It did last time anyway. I think what I did is I hit one of the keys that I shouldn't have hit. All right, now, what am I doing in my tree? Well, that's because within the main program, I called this, I build a tree. And in building a tree, it goes over here and sets it up. So I have to hit F11. I go through there. And now I'm back here, finally. So now I'm ready to push the tree. Look what happened. X has changed. It has one variable in it, and that variable is E, and it has 4B2 as its value. That is in hexadecimal. If you want to read that, you should read it as 2 plus B stands for 11, A stands for 10, C for 12, so on. 11 times 16 plus 4 times 16 squared. All these numbers are given in hexadecimal because that's closer to 10 and the base 10, then if getting it in all zeros and ones, we go nuts getting it in zeros and ones. So what I'm going to do is I'm going to keep hitting F5 now and watch things change. You can see that more and more things are going into the priority queue. I'm reading in the letters and the frequencies of the letters. I'm creating a tree for each of them, and I'm putting that tree in there. Now 1/8. 1/8 is 16 plus 8. That's 24. 1/9 is 16 plus 9. That's 25. We've got all the letters in. They go from 0 to 25. Let's look at our array. There they are. And you can see they keep going. Yeah, there I am down at the bottom of it. I'd rather go up near the top, though. Now, the way this algorithm is supposed to work is it takes the top two elements with the J and the K, which have the smallest used numbers here, and it's going to create a new tree with those as the left and right trees, subtrees. So I hit F5, and I'm down here, and you'll start seeing me set up some things. Lots of things are changing. I just hit F5 2 or 3 times. So let's see what's happened to the array. Well, now I've got an element that wasn't there before, and its value is 1117. Let's look at that value. That value is a tree. It has a left child and a right child. If I look at the left child, it has a left child. And if I look at that left child, it does not have a left child. But then I can go to right child, there was none. So I have one left child, Z, of question mark. Do I have a right child question mark? Excuse me. That would be right here. And yes, I have a right child, which is J. So the things are getting in here, more or less right. If I go back up and hit the X again so I can see only the parts that I care about, I'm going to make that smaller. You will see I've already created at least two new nodes, because I make my new nodes with question mark at the top of them as the value. And they have been put in where they belong. I don't have to do that myself. I put them in exactly the place according to their value. The value of this is 1C. That actually is 28. And 28 is above D1, which D is, that's 1 times 16. This is D times 16. D is 13. And you can do the arithmetic. I don't feel like it. But let's watch a few more times through here. I'll click this a few more times. And you notice the size is going down because I'm taking out 2 and putting back 1. So now you can see I have lots of these new nodes that I created. And I could, if I wanted to, show you a long, long list of left child, left child, left child, left child. The point of this is really that you can look at things. You can see what's there. You can see that things are going where they should go. It's great for if you feel like you're stuck in a loop you can watch the variables as in that loop. Remember, you have to put the breakpoint where you want to learn something, where you want to look at the variables. And when you're ready, you can either go to debug and say start debugging, which will be there, or you can just hit F5, which is easier. And I'm going to stop the debugging right now by clicking there. And now I can finish the whole, I could do a control F5 and the whole program would run. So that is the basics of debugging. There are other things you could do, but I think just that will give you a very good way of finding errors in your program. So long now.